All right, so as we talked about the 4 security services, privacy, authenticity, integrity, non-repudiation, and I said, yeah, most people do think about privacy, and with good reason. Historically, what cryptography has given us has been privacy. So what I have here on the slide is a little conceptual idea of what provides us with encryption services or privacy. And the little formula, plaintext plus an initialization vector plus an algorithm plus a key equals CipherText. So I want to talk about each of these elements and make sure that we understand them. And some of this may be a little bit basic, and that's okay. So if you've got a history of working with cryptography, that's fine. We'll get more sophisticated as we move forward. All right, so the first thing I want to talk about, plain text, that's easy enough. We know unencrypted text will also be called plain text, and that's where our starting point is. The next piece, an initialization vector. Now, let me tell you, you don't always have to have an IV, an initialization vector. You're going to have an algorithm and a key. But the IV, initialization vector, is optional. Okay, so what does an initialization vector do? An initialization vector adds randomness to the beginning of the process so that we get more randomness. And randomness is important with encryption. We always want to remove our ciphertext as far away from our plain text as possible. So even though we have a random set of processes, and that's very good, when we start with a random point, that just increases it. So an IV is a random starting point to produce additional randomness, to add complexity, if you will. Now, I have randomized starting point. The problem with that is a computer can't really generate random numbers, and you're probably aware of that. A computer can't just go 37. So what we have to have is we have to have a pseudo-random number. Okay, and that pseudo-random number might be based on several different variables, might be based on many different variables. And if we did something very basic, like let's just say we took today's date, and we took the time. So let's say it is November 10th, 2014, with a time of 11:15 and 37 seconds. Okay, maybe these numbers are added up. 1 plus 1 is 2, plus 3, so that's 3, 4, 8, 9, 10, 11, 16, 19, 26. All right, so this being a number that's going to change, because if we go back and say, what's the initialization vector next, these values will change because the time will change, whatever. This is a very basic process. This isn't something a system would use because it's, like I said, it's very weak and very basic. But it's the idea of something that's not really random, because this is based on system date and time, but that it feels random. So it might be CPU clock cycles, internal temperatures, could be some variable based on the key. It doesn't really matter what it's based on, but the idea is that it's always based on something. It's not truly random, it's pseudo-random. Okay. Now, with the next piece, the algorithm. The algorithm is a collection of math functions. Because when it comes right down to it, it's math that allows us to substitute one set of characters for another. There has to be some sort of pattern or some sort of technique that allows that substitution. So you've got 2 types of algorithms. With your algorithms, those algorithms are either symmetric or asymmetric. Now our focus today will be on symmetric algorithms. Actually, not our focus today, but our focus for the first part of class is going to be on symmetric algorithms. And they're pretty easy to understand. You know, symmetric, same. The same key is used on both ends. So I will use a key to encrypt. You'll use that same key to decrypt. Now, other names for symmetric cryptography: private key, secret key, shared key, which seems a little counterintuitive. I'll explain that one second. And then session key. Sometimes I think the hardest part about symmetric cryptography is remembering all the different names it goes by, and they will use these names interchangeably. So when we talk about symmetric cryptography, private key, if I'm going to use a key to encrypt and you have to have that same key to decrypt, we better make sure that we get that key and we keep it secret. It's private between the two parties. But it's also shared between the two parties, not shared with everybody, but shared between those two parties. Shared kind of feels like it doesn't fit in, but it does. We'll also talk about session keys that are symmetric, and the big difference here is your session key is limited based on time. And it's always a good idea, rather than using the same static key again and again and again, it's always a better idea to have it time limited. Use it for session, then you dispose of it. Okay? And with your symmetric algorithms, those symmetric algorithms will either be block or stream. And we'll talk about the differences between the two in just a few minutes. So all symmetric ciphers are going to fall in the category of being block ciphers or stream ciphers. And by the way, another word for algorithm is cipher. There'll never be a reason I use algorithm instead of cipher or cipher instead of algorithm. The two terms are interchangeable. Okay. So all symmetric ciphers or algorithms are either block or stream. And then later on, we'll talk about asymmetric ciphers. But asymmetric ciphers aren't block or stream. They'll use something called discrete logarithms or factorization. All right, so this is just kind of where we're going when we talk about algorithms. So we've got the initialization vector that gives us a point of randomness. We've got an algorithm that's a series of math functions or math processes. And we talked about algorithms are either symmetric or asymmetric. We're going to focus first on symmetric, also known as private, secret, shared, and session. And your symmetric keys, your symmetric algorithms are either block or stream. And then I've also alluded to the fact that we have asymmetric, which we'll talk about in a bit. And then the last piece we have is we have the key. The key is the instruction on how we're going to use the algorithm. Okay. So I've got all these different math functions. What do I do with them? Which math function is used? How many math functions are used? What order? How does it work? All of that comes down to the key. So whatever provides the instructions on how to use the math, we refer to that as a key, and the key is sometimes called a crypto variable. Crypto because it's part of cryptography, and variable because that key should change. It should be a randomized key. So these are some very basic definitions or ideas that I want you to have. Everything that we do is going to build on the idea of we start with a plaintext, then we use an IV, an algorithm, and a key, with ultimately the point of transforming our plaintext into CipherText. And that, again, to give us the security services of privacy and confidentiality.